So it will be an like a what oblique or vertical projectile discuss the same concept. What is the basic concept here? Like here the weight mg will act, and it is projected with a speed u at an angle theta. So under action of the weight mg and the velocity, the projectile is going to move and is going to describe a parabolic path and will come and strike the ground. And it will strike the ground with a speed v. We'll assume some all the data. It is projected with a speed 10 meter per second. Let me choose some easier value. Then theta 10 meter per second. Theta, let it be 30 degrees. What is our basic discussion? The projectile is going to move in a parabolic path and will strike the ground. It will strike the ground somewhere at a distance. So this particular thing, we'll call it as a range on the ground. And it is projected with a speed u at an angle theta. At what instant of time? At t equals 0. So how do it will move? As usual, again, I'll stick on to the same basic concept. So when you project here, because of speed and the weight, the resultant path. And again, at this point, it will have velocity, say v1. So it will have velocity v1 and weight mg. Again, it's moving a curved path. This is at highest point. It will have velocity u cos theta or v2. Here, velocity v3. Here it will have speed. Here velocity v4. And finally, it will strike the ground at this particular thing. So this will become time of flight. Now let's discuss some small ideas. These things at t equals it is projected. Let's come for this one. Again, due to velocity, weight, it will move in a parabolic path. So this will be the trajectory here. The ball is going to move in a parabolic path and will strike the ground. Fine. So these are the various positions of the ball. Then what about the acceleration? G is acting in this direction. What is acceleration along y-axis equal to G? Acceleration along x-axis is 0. How do this G will act? Opposite to initial velocity. So we will assume some, this will be u cos theta, u sin theta. And as it moves, what will happen to horizontal component? Everywhere here also it will remain constant. I think that basic diagram. So some rough diagram I'll give it. And the projectile moves. Everywhere the horizontal velocity has to remain constant. Where the vertical component will keep on change. Here it will be how much? U cos theta. Here it will have some P1y. Here u cos theta. Here it will be u cos theta. V3y. U sin theta. U cos theta. And finally it will strike here. Here it will be u cos theta. And it will have some velocity. This won't the basic clear. This one background is what you needed. Rest of everything, we are going to apply the kinematics. The horizontal velocity will remain constant. The reason for that, because this ax will be 0. I'll write it here. And ay equal to g. At t equals 0, we have projected. So t equals 0, the ball will be on the from the tower we have projected. We are just discussing this. What is the topic? Projectile motion from the tower. Okay, we'll write all the basic equations here. First, so this is the initial point. This particular point, we'll call this as initial. This particular thing is called as a final. So when the ball moves in a curved path like this, or a parabolic path, what is the displacement? The displacement is what, like vertical displacement is what I'm asking. And what is the vertical displacement? Will be equal to only this h, no? I'll indicate here. This will be fine. So when the ball moves from in a parabolic path, what is the vertical displacement? That should be equal to only this h. And how do this displacement is there? Opposite to this u sine theta. So therefore, we'll write first one equation. Minus h is equal to u sine theta t minus g. Why do this negative sign? Because this g will act opposite to u sine theta. Okay, fine. Then why again h negative? Because this displacement is measured downward and it is measured opposite to sine theta. That's why this will be considered as negative. Fine. Okay, now we'll substitute the values. We'll substitute the value. What is h? H will be minus 40. U will be 10. Sine 30, 1 by 2. T, this will be minus 10 by 2. T square. So this will be minus 40 5t minus 5t square. So 5t square minus 5t minus 40 equal 0. This solving this quadratic equation will get that time. 25 minus 4 AC. So this will be plus 4 into, I'll write down all the things. Some of you are getting confusion. Sir, why? Minus 4 is 5. This is 40. 4 divided by 2a. 2 into 5. Solving this, 5 plus or minus 25. This will be 4 5 are 20. 800 by 10. Okay, we'll get 825 by 10. Root of 825. Let me calculate it. Root 825. 28.7. So 5 plus or minus 28.7 by 10. Okay, usually what time will take it? The time should be positive. So the positive time will be t is equal to, positive time will be 3.37. Okay, after 3.37 seconds, it will come and strike the ground. Can we calculate now the range? Okay, we got this time. So this time equal to how much? 3. 37 seconds. Then we'll calculate the range. So how to get the range? Range is equal to, again, I'll apply the equations of motion. So again, the ball, when it moves from the point of projection to here. So what is the horizontal displacement given by the range? So what is the equation we should write here? This should be equal to, R is equal to U cos theta t plus ax t square. What is the horizontal acceleration along x-axis? 0. So therefore, this should be equal to U cos theta t plus 0 or only U cos theta into t. Substituting all the values. U is how much? 10 cos 30 root 3 by 2. This will be 3.37. 3.37 into 1.73. 29.15 meter. So where do it will strike at a distance of 29.15 meter? These are our answers, sir. This is one answer. Okay, great. These are all our answers. Time of flight and range. Can we calculate this speed also? I want this speed. With what speed it will come and strike the ground? How to calculate the speed? Okay, then already we know that one. Horizontal component remains same. Vertical component we should calculate. How to calculate that one? We'll use the formula. Vx equal to U cos theta. What about Vy? Vy again will calculate like this. Vy square minus Uy square 2 times Ay of h. Substituting all with sign. This is Ay into h. Well, I'll substitute all the things with sign. Once again, everyone, students should really ask this particular specific thing. So why Vy negative? How is Vy? Opposite to U sin theta. Why G negative? Opposite to U sin theta. Why H negative? Because when the ball moves from here to here, what is the displacement? The displacement is measured in this direction, opposite to U sin theta along y-axis. That's why all these quantities, they're having the negative sign. All these quantities, they're having negative sign. Fine. Like this, we'll substitute all the values. Vy square minus Uy square. U sin theta whole square 2 minus 10. Tower is, height of the tower is minus 40 meter. So this will be Vy square. U is 10, or this will be 25 equal to 800. Vy equal to 8 root 25. 28.7 it will come. Then what is the total speed? The total speed is given by Vx square plus Vy square. 10 square 825. 925. What about the angle? Yes, it will strike at some angle where tan phi equal to Vy by Vx. Almost all the quantities we can find out. So what is the quantity we have determined? The speed, units, meter per second. Okay, fine. So this is about the when you project a ball from a tower of height h. So we can use this basic method. So once again, let me summarize. So we have projected a ball with a speed u at an angle theta because of weight. The trajectory will be parabolic and it's going to describe parabolic path and it will come and strike the ground. It will come and strike the ground with a speed v. It will strike the from the tower at a distance r. So this is called like a range. And it will take some time. So what are the unknown things? First we'll calculate the time, then the horizontal range from the foot of the tower, then the speed with which it will strike the ground. So all these things we have determined. This is the time of flight. Fine. There's a range, and this is the speed, and there's the angle. Let me take the next condition.